Elementary Algebra Final Assessment 2 Review Questions 11 through 13 Outcome 4 Applications. In question number 11, you're asked, tell which brand is the better buy. To do this, we're going to set up each brand as a ratio. Brand A has 42 ounces for $5.46. So to find out how much per ounce you're going to pay for brand A, we will set it up into the fraction form $5.46 divided by 42 ounces. When we divide $5.46 by 42 ounces, it results in 13 cents per ounce. Let's do the same for B. B, we're told that we have 36 ounces for $3.96. So we're going to take that $3.96 and divide it by 36 ounces. This results in 11 cents per ounce. So in looking at both brands, brand B is going to cost less per ounce, only 11 cents per ounce. So brand B would be the better buy. In this section, you're asked to solve the problem. Question 12 reads, the 16th hole at the Riverwoods Golf Course is 375 yards long. How long would it be on a model with a scale of 2.5 inches to 75 yards? To solve this problem, we're going to set it up as a proportion and solve for their cross products. So in looking at this, we read out that the model would have a scale of 2.5 inches to 75 yards. Let's set this up in a fraction form. So we have 2.5 inches to 75 yards. On the other side, we would want to put the same information in the same position. In our numerator's position, we're going to have inches. In our denominator's position, we're going to have yards. Let's go back to the question. It says that the 16th hole at the Riverwoods Golf Course is 375 yards. So we have the denominator's position on this proportion on the other side. What we don't know is how long it would be on the model. Because we don't know, we're going to put in a variable. In this case, I'll put in the variable x. Now we can take the cross products. So we'll simply multiply across. So we'll have a 75x equal to a 2.5 times the 375. Let's simplify. 2.5 times 375 will get us 937.5. We'll simply carry down the 75x for the moment. Now, continuing to solve this problem out, we want x alone, so we'll divide out the 75 on both sides to clear the 75. We're left with x as being equal to 12.5. If we look back to our original problem, that 12.5 has the units inches. So to finish our problem, we're going to write this as 12.5 inches. Let's continue to solve the problems given. In question number 13, it says, hey, Ron, who is 1.58 meters tall, wishes to find the height of a tree. She walks 20.84 meters from the base of the tree along the shadow of the tree until her head is in a position where the tip of her shadow exactly overlaps the end of the treetop's shadow. She is now 6.17 meters from the end of the shadows. How tall is the tree round to the nearest hundredth? In this problem, we are provided with a picture of a person or stick figure and the tree to help us try to solve the problem. Let's fill in the information on our picture. We know by reading out the information that our person is 1.58 meters in height. So we can place that into the problem. The next thing that we know is that this person walked from the base of the tree to their current position, and it was 20.84 meters. So let's put that on there, 20.84 meters. We also know that the person stopped when their shadow reached the end or the tip of the shadow of the tree, and that distance is 6.17 meters. With this information, if we look carefully, what we actually see are two individual triangles that have been created, a smaller triangle inside a much larger triangle. So if we pull these two triangles out from one another, we end up with one triangle, or small triangle, that's 6.17 meters on one side and 1.58 meters high. We also end up with a much larger triangle. This larger triangle is actually coming from the tip of our original to the base of the tree. We know by looking at this one that it's going to be the 6.17 meters plus the 20.84 meters to create the base. What we don't know is the height. That height is the height of the tree, which we're attempting to solve for. We have two triangles now that are proportional to one another, so we can set up a proportion. We have our smaller triangle at 1.58 over the height of our person at 6.17. On the other side, that 6.17 came from the base of this triangle, so we'll take the information from the base of our second triangle, and that is 6.17 plus 20.84. What we don't know is the height of our triangle, which is also the same as the height of our tree. So we'll put that x in that position. Now we can continue on and solve the problem out. Let's start by simplifying. We need to add that 6.17 to that 20.84. This results in a 27.01. We'll pull everything else down. So we have a 1.58 over a 6.17. To complete this, we're going to take the cross products. So our cross products in this case are going to be a 6.17x equals a 1.58 times a 27.01. And simplifying, that 1.58 times 27.01 becomes 42.6758. Carry down the 6.17x. Lastly, we want to divide out that 6.17 from both sides of the equation. We're left with x being approximately equal. Now if you punch this into your calculator, it's approximately equal to a 6.9 1.6661262. It kind of just continues to carry out. If we go back to the original problem, we see that it says to round to the nearest hundredths place. So in this case, that's going to be where this 1 is, right here. We look at its neighbor to decide if it's going to stay the same or if it's going to round up. We see a 6. Anything a 5 or above would result in the number rounding up to the next value. So our answer is approximately equal to a 6.92. Lastly, don't forget to put those meters back on there. You can abbreviate meters with just an M, but be sure that it's there. It's part of the answer.